Voila. And who's next? I'm going to do the resistors quick just because they're right there. And also more than likely they'll actually come out. Sockets are iffy because they're made of a bunch of individual contacts in a relatively low melting point plastic carrier. So there's usually not a lot of plastic even there holding the pins in, holding the pins in. And once you get some heat on it, it starts softening pretty quick. So my luck at getting sockets out is, well, mediocre at best. Resistors and ICs, which I can bake a little hotter, make sure I get good flow on the solder before I pull them out, tend to go a lot better. Yep, didn't completely get all the solder out of these. Got a couple that are stuck. And how am I going to find them? Now what I'm doing here is, after I suck the solder out, there's still, you know, a little skim coat of solder on the pin and the hole. So sometimes once it cools, it'll just make a very minor connection, joint, between the two. And if I just flex them a little bit like this, I can break that joint and then the socket will come out of the hole much easier. Now if this was a regular IC, there's enough strength in the body that when I pried up on it, it'd break those little minor connections and pop right out. Now here you can see I got some pins that I didn't completely unsolder on the one side of the socket, so I'm going to have to hit those again to get them out. But still, I got the most of the socket out, and that can go into that pile. Again, I typically don't reuse sockets, or I should say I typically don't reuse sockets once I desolder them. One, heating them up and pulling them out typically weakens the joint, so they usually fall apart like this. And two, if it's been sitting in a piece of equipment a while, there's no guarantee what the surface of the contact looks like. So here's one of the contacts here. When you push a dip in here, it just wipes against this surface here, and the spring tension of that contact is what makes the connection to the IC. Now, if this spring had gotten weak over time, or this surface had gotten corroded, that connection would be suspect and probably just cause you more problems in the long term than spending the, next to nothing to put a new one in. So that's done now. Where to go next? Well, I got this quote speed button. I'm kind of interested where he goes. And another interesting thing about it is you see here there's a connection on this side that goes over to there, and on the back side they have a wire between the same 2 points. So apparently they must have had problems with soldering these switches on, and that was the fix. Just a little weird. So I could trace him through. There's also this 125 right here that's he's hooked to this data bus, 4 bits, but and he's got some loops on him. Oh, and then he went over here. So you got a bunch of stuff off of here. And it went to this connector that used to go off card. So he might be a good shot to get rid of next. That will clear up this path. Also, this chip is being controlled by that chip. So if I can get him off of here, that'll tell me quite a bit more. First up, what's a 125? There is something I want off of here before I close this for the umpteenth time. Leave that there. So I want to just mark where the data bus pins are for future reference. So it looks like D0, 1, 2, 3, 4 are around the center here. So I'm just going to paint the pads sort of black. And then it skips to in 4, 5, 6, 7. So it looks like this chip is on the high order of the bus, and this chip's on the low order of the bus, and both of those chain back into the bus to the DRAM. So this may be an extension of the memory data bus. Not the address bus, just the data bus. Now, there's also some write enable, chip select, read enable type pins out in this area. In fact, it's probably these ones right here. One up from the bottom is read. Skip 2, that's write. And the chip selects go somewhere off that way. So we'll have to figure out exactly how those tie into the rest of the world. But for right now, I want to investigate this button or this IC right here. I have my suspicions, and if they're right, it can go away. So that's what I was going to do. I was going to look up a 125. 125. There's a 125. Okay, quadruple bus buffer with tri-state outputs. So, depending which one you pick, it's a non-inverting buffer, which when the gate is low, the output is on, I do believe. Let's see if I can find a waveform for this guy. Yeah. So yeah. So when the gate is low, it transmits data from A to Y. So now let's figure out which way the bus goes. Pin 2 is A. Okay, pin 3 hooks back to the data bus, which is Y. So this is an input buffer. And I bet you 1, 4, 13, and 10 are all hooked together. So, it's making this yeah, that's just a big wide buffer, and I wonder if it's, yep. So these two buffers the gates are wired together, so they act as one 8-bit wide input buffer when that address is selected in memory space. Now, this one has the upper 4 bits, this one has the lower 4 bits. I'm just going to concentrate on him and find out where in the world he goes. And I think he goes... Yep, that pin goes to that connector. That pin goes to that connector. This pin should go back to there. I'm surprised that one of these three okay, I got it. A and Y are 9 and 8. Pin 7's ground. Yeah, that's definitely ground. So, come on. Y is pin. This is the output, or input, depending on how you look at it. But it's not hooked to anything. That's... I either have it open. It's got to be connected. I must just be getting a bad connection. Boy, that's really weird. This pin here. Yep, that goes there. Yep, all these bits go over there except for this upper bit. I can't find the connection to this guy, which I'm pretty sure it's supposed to be this one. But maybe I just nicked the barrel and soldering it. Yeah, that's what it looks like. Yep. When I pulled this pin out of this barrel, I nicked the top pad off, so it ripped this connection open. So that's one thing I got to be careful about as I'm pulling these parts off. If I pull a chip in the middle, I could accidentally disconnect the trace coming in versus the trace going out like I did right here. Good news is this chip only goes to this I/O connector, which I don't have the part for anyways, so he can go bye-bye. Now, had I actually needed that chip, it'd be a simple fix of just running a piece of wire through the connector hole, or through the hole, and then soldering the traces back together on either side, or just filling the barrel full of solder. See, like right there, I just ripped part of that pad off. You know, you want pressure so the heat transfers, but you don't want so much pressure that you delaminate the printed circuit board from, or the copper from the laminate, which is the fiberglass layering. Okay, let's see if I can pop this chip off. Yep, there he goes. And there's a gate-controlled quad buffer. Now these guys right here are just little bypass capacitors. What their job in life is to do is to absorb the little instantaneous current spikes these chips generate when they switch and quiet the noise propagating down the power rails, so that when this chip switches, he doesn't make a big noise spike that goes and screws this chip over here up. So back in the TTL days, it was very common to see one of these little caps by every chip, and typically there are 0.1 microfarads, and this one is labeled 0.01 M. So this might be a 0.01 microfarad. Anyways, they're not very big. They're just to take the instantaneous little noise spike, take the crisp edge off of it, and you sprinkled one per IC back in the day. Nowadays, with the bigger ICs with multiple power domains and just the sheer number of gates in them, you need several decoupling caps of various values to try and dampen that electromagnetic noise on the power rails. One, to keep it from radiating out into space and getting the FCC all upset with you that you're interfering with radio waves, and two, to quiet the power rail so you don't have all this gibberish noise coming in on your voltage rail, causing the internal guts of a chip over here just to go sort of off into la-la land. What's next? I think I want to check this chip out. I have a sneaking suspicion that the data and control lines... Nope, I take that back. This is read and write. And as you can see, they sort of come up and hit pins on this EEPROM. So I wonder if these two corner pins are read and write. So let me go see if I can find the data sheet for that guy. 6514, yes. So address pins are on the bottom side, data pins are up in this corner, and that last pin is right.